we have a project to create a petrochemical vulnerability index for more than 2,000 marine species across the entire Gulf of Mexico large marine ecosystem, so both North and South Gulf. So the idea behind the project is that we don't have a lot of toxicology data for the vast majority of marine species that are present in the Gulf. And we're using an approach to try to estimate which species might be more sensitive to oil and gas exposure and which species may be more resilient to oil and gas exposure based on two things. One, the probability of exposure. Are you in the right place at the wrong time?
Right.
And two, what about you makes you more sensitive or resilient? What kind of life history traits do you have that may make you more resilient or more sensitive to exposure to oil and gas? 99.9% of species in the marine ecosystem in the Gulf of Mexico, we don't really know anything about how they will react to exposure to oil and gas. Mostly, we use common test organisms in our studies of how animals react to exposure to oil and gas. And that's good because it allows us to standardize results across lots of different chemicals. But we don't have information, for example, exactly on how whales or sharks or sea turtles may react to exposure to oil and gas, simply for logistics. You can't take a whale and bring it into the lab and throw some oil on it and try to figure out how it's going to react. So our approach is to stay out of the lab and to try to use what information do we already know that we can use to estimate which species may be more vulnerable and which ones might be more resilient to exposure to oil and gas in the Gulf. So we're completing our first year of the project as of January 2019, and basically the past year we've spent doing massive literature review, compiling all sorts of data for, again, 2,000 species across the entire Gulf. And these include all known vertebrates, so all known species of marine mammals, sea turtles, seabirds, bony fishes, sharks. We're also compiling information on all known invertebrates and complete taxonomic clades, so all sea cucumbers, all cone snails, all lobsters, all cephalopods, all oysters, all corals. We're also working with a couple of marine plant groups, the mangroves and the seagrasses. So if you add up all those together, there's about 2,000 species across the entire Gulf. So we spent the past year compiling as much data as we can on all 2,000 species, including all of their life history traits and any available toxicological data that's been conducted, either through searching, the Web of Science, literature reviews, looking at the GRIIDC database from the GoMRI projects as well, talking with other scientists and going to different databases to try to compile all of the data on these species' life history traits and any available toxicological information. And what we found is what we expected. Very few groups have any information at all in terms of toxicological response. The vast majority are bony fishes, have been the most studied. Inverts and plants, a lot less so. Right, so we found huge data gaps in our understanding of how species respond to exposure to oil and gas, which is really no surprise. But what we're hoping to take this project to in the second phase, the second year, is we're working with scientists from Cuba, Mexico, and the United States to come together to help us take the data that we've collected and create a methodology for how we will use these data to develop our final petrochemical vulnerability ranking. So in other words, ranking these 2,000 species on a scale of 1 to 100 each, 100 saying being the most vulnerable and 0 being completely resilient, and attaching some confidence interval, using some statistics to deal with like zeros in the data or uncertainties in our probability of exposure, to help prioritize which species we may need to look at first, or we may need to mitigate first, or we may need improved management for in the event of exposure to oil and gas. Yeah, so this is exactly what we're hoping for. This final data set for all species, including updated distribution maps, will help first responders, when there's an oil spill, they can look at the data and say, okay, what are the species here that exist right here where this oil spill occurred that may be the most vulnerable that we need to look at first? Or maybe if there are plans to do oil exploration or decommissioning of a platform or create new shipping lanes, for example, what are the species that occur there that may be the most vulnerable that we may either need to avoid Or maybe there's actually a group of species there that are really resilient, and this might be a good place to do oil exploration or create a new shipping lane or decommissioning or expand our activities. So it helps to prioritize which species in which geographic areas may need more conservation or actually may be more resilient and maybe good places to do more oil exploration.